Welcome to Sigma Solver, guys. Before I start the video, I want you guys to smash the like button. This helps the YouTube algorithm and keeps me motivated. And if you are new here, then subscribe to my channel and press the bell icon so that you never miss an update. So without any further ado, let's get started. Today we are going to look at a different topic which is similar to what we have been doing in previous videos, basically related to computer graphics. We are going to look at midpoint method for drawing the circle. So let us read the question first. Write down the midpoint method for circle generation with center at origin, radius equal to r. Explain the procedure in algorithmic form and hence draw a circle with center at origin and radius 6. Write some drawbacks of the method. Right, so first we will start with the introduction. In computer graphics, we often need to draw circles in raster displays, the displays which we use in monitors and PCs. Unlike continuous math, we can't plot fractional coordinates directly. Instead, we approximate the circle by choosing the nearest pixel position, which we will see in the video. Now, this midpoint method is basically a variant of the Bressenham algorithm, which we have discussed in a previous video. This is used to generate a circle efficiently by using only integer arithmetic. This is the keyword. No floating point multiplication or square roots. This exploits circle symmetry. Only 1/8 of the circle is calculated and the rest is basically mirrored. Decision parameters to choose the next pixel closest to the true circle, right? These two will be the key entities in order to proceed with the midpoint circle generation algorithm. Now obviously the question comes where it is used. So it is used in computer graphics, game development, CAD and CAM, as well as in embedded systems. Computer graphics is just as we saw in drawing the different shapes specifically related to circles. In game as well, different characters and shapes that are involved. CAD, computer aided design, is obviously going to use this, and embedded systems for hardware constrained scenarios where like we are only subject to have integer calculations. Okay, next we go to the actual problem. So we are given the circle equation x square plus y square equal r square and the center is 0, 0 with radius r. Now the steps to solve would be, first we know that due to 8-way symmetry, only one octant, which we will see, that is 90 to 45, is what we will do in like step by step, and the rest of them will be computed as symmetrical entities, right? The other points will be mirrored, right? Next, the decision parameter. So at any step we test the midpoint between two candidate pixels to decide which one is closer to the circle's actual path, right? So the starting point x comma y is 0 comma r, okay, because it is kind of this particular place, so it will be 0 comma r. The initial decision parameter for this scenario would be 1 minus r, right? We'll see the more detailed version of this below, so don't worry. The update rules would be, if p is less than 0, choose pixel east. Now where does this east come from? We'll see that, but down below. But let's look into the problem first and the updation rules. So the next point in this case would be x plus 1 comma y. For now just imagine that this is east, right? This is south, right? So this would be southeast, okay. So then the update rule would be pk plus 1 equals pk plus 2x plus 3. But if p is greater than or equal to 0, then we need to choose the pixel on the southeast, right, which is x plus 1 comma y plus 1, right. Then the update rule would be pk plus 1 equals pk plus 2x minus 2y plus 5. Now again this p calculation is something which is subject to derivation and problem solving analytical skills. So if you do want a derivation on those as well, then do mention in the comment section below. Now we'll understand what is this east and southeast. So I'll zoom in a bit. So here you see like the circle that we are trying to draw. Mostly it will fall up till this part. So this is the y axis, this is the x axis, and most likely we are going to stop at this stage, right, which is kind of the 45-degree angle. Now just to make it a bit clear, I'll just remove this one so it doesn't intersect the actual point. I'll mark this as 45. Okay. So let's suppose this is a very small grid, right, which we are zooming in to see this one, and these two dashed lines are kind of the grid lines, right, and this solid lines next to y in the vertical is another grid line. Okay. So when we are at this point, which is the, I'll say I naught initial point, and we want to go to the next point, right, the next point meaning either it will be E or SE, right. Now what will be the coordinate of I naught? Let's say it is x naught comma y naught. So then E would be x naught plus 1 comma y, and SE would be x naught plus 1 y minus 1, correct. Now this would mean that, okay, this particular case would be y minus 1. So just a small mistake here. So in that case, what we are seeing is this particular line, which is the actual circle, is going in between the midpoint of these two, E and SE and E, right. So whenever it does like this, we'll choose E, right, because from the midpoint and the point E, it is closer to E than it is closer to SE, correct. Had it gone via this route, then we would have chosen SE, right, and if it passes directly via midpoint, then we can choose either of them. It doesn't really make a difference, right, but the essence is this particular grid distance is so small with respect to the size of the circle itself that it is hardly negligible, right. So that is kind of the thing. Now zooming out from there, we'll see the algorithm step by step. So the first is input radius and center. Next, initialize these ones. So it is a good practice to basically take the same kind of starting point each time for each circle, right. Obviously the center would not be as simple as 0 comma 0, but the idea is to start from the top of the circle vertically and then move towards the right hemisphere in this direction. Okay. So we take x, y and p, then while x is less than or equal to y, we will plot the points using 8-way symmetry, x comma y, y comma x, minus x comma y, minus y comma x. Same is the case with the other parties, x comma minus y comma minus x comma minus y comma minus x. So with this being said, now we are going to calculate the next p. So if p comes out to be less than 0, then we will have p equals p plus 2x plus 3. Otherwise, p will equal to p plus 2x minus 2y plus 5, and y will change from y to y minus 1. And in both these cases, x will continue to increment further. And for those of you guys who are questioning on this one, so this basically marks the point when x is equal to y, which is nothing but tan theta equal 1. Okay. So now we will see the actual example itself. We have the circle with radius 6, center at 0 comma 0. We initiate those values. Then these are the iteration steps. So first 0,6, we see p equal -5, so we choose east as per the algorithm, which is 1,6, right. So it is p equal 1 again, then 1,6 and p1 we will choose SE since p is positive, and likewise we will just keep on calculating, right. Now at this stage after 3,5 we will find that okay, or after 4,4 I must say that x is greater than y, correct. So there we need to stop, right. Each step mirrors across all 8 octants to draw the full circle. So that is why we stop. Now we just follow these particular guidelines which I have written here, right, in order to get the other points. So now we will look at some of the drawbacks. So first, it works well for circles, right, but for ellipses it is a slight bit different, and we have also uploaded another video for drawing ellipse by using the midpoint method. I will link the video in the I button here. Then there is integer only approximation, so circle may look a bit blocky at smaller radius, right, but for regular and larger radius it would be fine. The other drawback is it is still quite iterative, right, for large radiuses it is not constant time per pixel, so that is an issue. Next is it is limited to raster graphics. These days vector representation in Adobe Illustrator and many other softwares are also there, which are mainly used for graphic designing irrespective of the size, right, whatever be the size of the rendered entity, but since this is vector and not pixel, so the relative distances stay the same, right. Now the modifications would be midpoint ellipse algorithm, anti-aliased circle and arc drawing. Now on arc drawing it is a bit special because it is an extension of what we just saw. It will restrict the computation to a specific angle, right, and it is not like the complete circle, it is let us say 35 degrees, right, like that. So that is kind of the purpose of arc drawing, and since this is an arc, so again we can't use the symmetricity likewise, right. So that is one thing. Some other topics would be like integration with GPU rendering pipelines, sub-pixel precision algorithm and 3D rendering. Many of these along with the modifications we discussed like arc drawing have been discussed in the Sigma Solver community, right, along with some other questions on this same topic. So if you are interested in joining the community, then you can join by clicking the link in the description below. If you still have any doubts, then feel free to reach out in the comment section below. If you liked this video, then give it a thumbs up and subscribe to my channel for the upcoming videos. Till then, happy solving.
Hey there, before you go, I've got some fantastic content lined up for you. Over here, we've got some videos and playlists you might enjoy. But first, if you haven't already, make sure to hit that subscribe button and ring the notification bell so that you never miss out on any of our future uploads. Thanks for watching, and I'll catch you in the next video.